So rename this folder to camera and light. These are called collections in this outline, and delete this cube and create another collection. Name this collection to parts. Cursor to origin and Shift A and create a new mesh which is in cylinder. Make the vertices to 200. Make the radius of the cylinder to 30 millimeters. And let's change the mat cap. This one looks good. Yes. And now let's change the depth to 80 millimeters. So we got the base of our geometry for the microphone. Now we're going to use Boolean methods to cut one shape with the another. And this is all going to be procedural. And first we're going to select this top face with all the vertices and go to the vertex group and create a new vertex group and assign this group to it. Then we're going to add a new modifier, and we are going to use a bevel modifier to bevel this area. Now here we're going to use a group that we have already selected, so only top part of it is going to be beveled, and the amount of beveling is 5 millimeters. So we got our first bevel on the top part of the microphone. Now we're going to use the Boolean methods. So we're going to use one shape to cut the another. So we're going to duplicate this shape using Shift D. You can see the shortcuts on the left hand side. And then we're going to rotate this. Rotate it downwards at 180 degrees. Move it a little bit up so it's intersecting with it about a few millimeters inside. And we're going to change the scale of the X and the Y axis. So we can see this another top part is coming out of it, and we're going to measure out to 0.8. We're going to keep this and apply this bevel because we're going to edit some part of it. The tutorial is mostly procedural. Just this part goes a bit into modeling. It's not much, as you would see. We can extrude this part on the minus Z axis. Select this top part and go to the modifier step, add a Boolean modifier, use the fast method to cut, and use this shape to cut into this top part. So we're going to use one shape to cut the another, and we can change one shape of the cutter, and it will automatically going to be reflecting to our geometry as we do. So it's a procedural workflow. So if you want to change things, you can do it on the way as you go. So we can duplicate this, top part, and I'm going to bring it a bit more downwards, about there. It looks good. Okay, let's do it once again. This looks fine. Now you can see the bevel area, so we're going to change the bevel area so it matches to our top part. Until it doesn't matches the top part bevel line with the internal line, we're going to tweak the value. So this looks good, 3.5. So what we're going to do with this, we're going to create an inner thickness of this, creating a shell, adding a bevel modifier and selecting this new shape. So you can see a top cutter had cutted the top once, a underneath cutter had cutted the underneath part. And on the end of this booleans, you can use a bevel modifier and add the amount of beveling on the edges, and you can change it as well, as it is completely procedural, so you know, however you like it, you can make the changes on the go through the modifier stack, selecting the base part shape. And you can also change the cutters, and it will automatically reflect and update to the main geometry. And this is the power of this workflow. This is called a non-destructive workflow. You cannot make mistakes with this one because nothing is applied, nothing gets destructive on the go. You can delete, you can reselect another cutter, and it will automatically update. So add a plane. We're going to create the grills of this mic, so we're going to cut the sides of it. Let's see what the size would look good. I'm putting in 50 millimeters at here. We're going to rotate it on the 90 degrees on y-axis, and I'm going to push it out to minus 30 meters. Actually, the millimeter, when you export this, you should export selecting all the parts and check mark the selected option, that only export the selected, and use a value of 0.001 and also change the scale to millimeters. And that's how, while you export in millimeters in the original scale. This just helps the Blender to calculate faster. I think with millimeters it's a bit slow and could get a bit more dicey at sometimes. So I think this one also gets well if you use meters just for making models and later on use millimeters. I think that should also work well. It's up to your choice at the end. So I'm adding a bevel modifier to this and making the mount to 5 millimeters. You can see the corners have been rounded out of this plane primitives, and I'm adding a solidify modifier to it and changing the offset value to 0. So from both sides it will going to be inflating out, and we're going to make this as big so it just reaches out from both sides, because it's going to go through this mesh as a cutter. So add a boolean, use indifference operation and choose the fast option and pick this new object that we have created, and we have successfully cut this, and we're pretty much on there, 80% on creating the top part of this microphone, or this condenser microphone. I can rename this to grill cutters So it's just easy to find out which cutters are doing what in the stack. If you are using this workflow after learning it, you must rename all the cutters so you just can find them easily. Putting them in their own specific folders and renaming them is a good way to keep things tidy as you go, because you can have like 20, 30, 50 cutters going on through a mesh, and it can just get really problematic to find one, as you can get loose of the track as you try to create things. So renaming and separating things into folders and keeping things tidy just helps you to find things out if you want to change or replace something. So make sure while you work you keep things tidy and make it and workflow. The workflow should be really tidy as you go. So I have made 2 different folders, top part cutters and bottom part cutter, because we're going to create 2 parts of this microphone. One is a top part and one is a bottom part. You can see we have so far created these 3 cutters, and these 3 cutters are on the place, and we can hide them and we can unhide them whenever we like. So far this has been created. Now what I'm going to do, that we have this small segment cut on this beveled line, on below of this bevel line. So we're going to create a new mesh circle. We're going to appraise the resolution to 100 and make the radius to, it's 31 meters. So the original base is 30 meters. We're just getting 1 millimeter more offset out of it. And I'm moving this to 34 millimeters on the Z plus direction. I'm going to modify stack and using a screw modifier, setting the angle to 0 and make the render and step views to 1, both to 1, because we're going to just extrude it so it has in geometry, unless it was just in a wire. Now this geometry, we're going to create a thickness, so this thickness goes inside. After 1 millimeters it will start to go inside, so after 1.1 becomes 0.1 millimeters. That's how we count on this mathematics. So 1 millimeters was offset. After 1.1 or 1.2 is just 0.2 millimeters or 0.1 millimeters. This is how we use this workflow. This is quite fast than the CAD ones that I've created. That is a bit more precise, really precise, but that can take a lot of time. So I'm just teaching this one so you can understand. Now I'm using a bevel modifier on this newly created cutter and making the segment up to 2, so it will create a bevel segment. So while it cuts inside the mesh, there would be enough amount of light to actually bounce back when you render, so it will just be more apparent to the view. And I'm using a bevel modifier on the main geometry. I'm using a Boolean modifier on the main geometry and selecting this cutter. You can see the cut has already been made. The cut on the original mesh that I've seen was as thick as this was, so on the close-up you might be able to see, on the renders you might be able to see. Here I have to zoom in a little bit for you to see, and you need to keep this Boolean after the bevel modifier, otherwise it can be, as it is when using a procedural workflow, it can actually create a problem with the top bevels. because it is actually trying to calculating the angles and can actually go into problems with those angles. So you need to keep it after the bevel modifier, so it just appropriately works. And the top bevel that has been created, that also doesn't get affected by it. So I'm creating a new mesh. This is what we're going to use for the grill. I'm using a cylinder primitive for this, and I'm making a group on the top part of it, and using a bevel modifier, we're selecting the group that we have created just a second ago and adjusting the amount. So we're going to go to the wireframe view to look about when it looks right and goes inside the mesh and doesn't intersect with it, then it looks right. And the bottom part, we don't need it because the grills are going to be on the outside and the top part, and on the bottom part there's going to be no grill because bottom part is just not going to have any voice. The grills are there to just protect the microphone. So in our internal parts, so yeah, let's apply this bevel. So it's procedural, and some of the parts you can just adjust on the way. And here we're going to add some loop cuts using Control R, going to edit mode, go to the wireframe view. You can view it. On the top part, we don't want this cutter to have a top part right now because it doesn't have the required geometry which we're going to use as the grills. You will know about in a minute what I'm doing. So name it grill and put this inside the parts collection and go to the edit mode and delete the top part. After deleting the top part, let's just hide this main part and go to the grill part that I've created and select this edge loop and select the grid fill option on the search panel. So we get this wires, and now what we're going to do is that we're going to go to the geometry nodes and I'm going to add a new geometry node to this. What I'm trying to doing here is that I'm going to use a mesh to curve node, and it's basically what it's doing, it's just turning the base geometry of it to a wire. And now we're going to use this wire by converting it to curves. So we're converting the mesh to curve and then curve to mesh, and while doing so we're using a curved circle to create the new geometry. Make sure the resolution is 1 and the radius is 0.1, which means that wire is going to have a 0.1 millimeter of thickness. Now if you are not happy with the thickness, how I wasn't been happy, you can change the radius of the wires to 0.2 millimeters and that would work. And now you see it looks more relevant and close to the real world condenser microphone, this top part. Okay, so far we have created the top part under 20 minutes. Maybe it could have been done a bit more faster, but well, looks it works. And this is the power of this procedural workflow. You can change things on the go, you can change cutters on the go, you can add things on the go, and things will become non-destructive and changeable. And this is the power we have so far. And it took me a lot of years and a lot of trials to create this kind of workflow.